we will go over the problems. First, quick side note, I have a slight typo here, this object-oriented programming, or OOP, but not OOP, number 2 quiz. It was supposed to be out of 8 points, 2 cubed, instead of 4 points. So that superscript 2 should be a 3. Each one of these problems is worth 2 points instead of just 1 point. So I have the 4 quiz problems opened up here in Python Tutor. We'll use Python Tutor again to go through these assignments or to go through these quizzes. This is, at least for a while, going to be our last one of these Python quizzes. We'll be going back over to the shell stuff here and back over to the terminal to do these quizzes in the future, though. Here, our class up here, foo, we have our constructor right here. Again, we don't go into these things when we first come across them, executing them. We just jump all the way down to the end of the class definition, creating the appropriate class object over here. Again, this is not an instance, this is a class. The class is the thing over here, the foo class. It's created over here a foo class, and then line 5 right here is going to create this lowercase foo instance. In Python, it is traditional for instance names, variable names to use this snake case. So everything is lowercase, and if you're separating words, you use underscores. And for classes, to use the uppercase camel case. Again, Python is a snake, so snake case is like the default normal thing, and classes are a little bit weird in Python, and this convention is just to remind you that classes, they're used all the time, but they're don't overuse them. They're a little bit weird in Python. When it's possible to do things without classes, we want to do things without classes. So all I've done so far is run this first line. When we execute this line right here, line 5, we have this uppercase foo, the name of the class right here. That's going to call the constructor, which is this init function. Constructor and the init magic method are synonyms for each other. Press next, come over here. We're now in the init method. Again, the foo instance instead of the foo class is what we're constructing. And here our message value is equal to hello world, because that's what we passed in right there. The hello world value here is what we call truthy in Python. So it is equivalent to true inside of an if statement. And if you have a string, the only falsy string is the empty string, but every other string is truthy. So we will go inside of this if statement right here and do the foo.message equals message. Again, anytime you have something to the right of a period, this thing over here, we call it an attribute if it is just a variable, or a method if it is a function. Methods are special types of attributes, just like functions are special types of variables. And every attribute is a variable, but just, I know it's more correct to say attribute when you're talking about this message rather than saying variable, because just helps everybody be on the same page. Make sure that you're talking about the message over here and not the foo. So it's the message attribute of the foo class. Over here, this is an uppercase foo referring to this right here, not to this down here, and not also to this self up here. This self would be referring to this instance over here. But because it's an uppercase foo, we're referring to the class object right here. So when I say foo.message right here, I'm going to create a message instance inside of this class. This is not this message right here. This message is the default parameter. The default parameter to the constructor, to the init dunder method or init magic method. That's what this message right here is. As soon as I press next, you can see we created a new message attribute inside of the foo class object right here with the value hello world. And that's everything that the constructor is going to do. Constructors will never have a return value inside of them, never have a return inside of here. And so it's not really correct to say that this constructor returns the value of foo. Really, this constructor is initializing it for us, but something else inside of Python is doing the returning. And so when I press next down here, this foo variable is now pointing over to this foo instance, which was constructed with the init magic method. Again, I'm just reviewing all of our terminology here. You're never going to be quizzed on any of these terms, but you will be expected to be able to follow along with them as I'm using them, and strongly encourage you to get into the habit of using the correct terms for things yourself. Part 6, line 6 right here, we're doing this foo.child equals foo. So this is an example of a recursive data structure because the attribute right here, the child attribute of this foo instance is also another foo instance right here. We'll run through this. In this case, the message is none because we did not provide a value right here. So we're just using the default value. We will not go inside the if statement right here because none is a falsy value in Python. Press next. Next, we'll skip over this whole thing and come down here. And now our lowercase foo is pointing to the child, or sorry, pointing to this foo instance right here. And the child, which is an attribute of this foo instance, the child is an attribute of the lowercase foo variable. The child is pointing to this other foo instance out here. And now we make it not only recursive, but we make it what's called cyclical, that as soon as I press next right here, the foo instance over here will have a child attribute created, So running line 7 right here creates this child attribute of this new foo instance. And we call this a cyclical data structure because if you just follow these arrows, you will be going sort of forever. There's no stopping these arrows anywhere. This is sort of analogous to an infinite recursion in recursive functions because if we were to follow these arrows forever, we would be in an infinite loop. There's no way to, there's no end to these arrows over here. But it's totally okay, or let's see. It is not okay to have an infinite recursion because that will run forever. You'll get the Stack Overflow error in Python. But it is okay to have these cyclical data structures. As long as you don't traverse these things forever, you'll be totally okay. So now the line 9 over here, tricky part. So we have to figure out exactly which instance is this referring to in order to compute the message. And so we start with foo right here, go to, there's first child, one child, then go to the second child, then go to the third child. Sorry, I lost count. Too many childs. So foo right here, first child, foo, here's the foo instance. This goes to, this is the child right here, first child, second child, third child here. And then we access the message attribute of this child. And it turns out actually it didn't matter which one of these two children we were on because neither of them has a message attribute inside of it. And whenever an instance object does not have an attribute, we don't immediately throw the attribute error. Instead, we look at the appropriate class for that instance, finding the corresponding attribute. In this case, the class does have the message attribute. And if I press next right here, it will print out the class's message attribute, hello world right here, hello world, and not give you an attribute error. If this had been self.message up here, you would have gotten an attribute error because only this instance would have had the message, but because it's foo.message up here, it doesn't matter which one of these two instances we're on, we do not get the attribute error and get hello world. Any questions about this first problem? Okay, hopefully this is reminding your brain about all the things that we learned before spring break. And again, each of these problems worth 2 points instead of 1 point. Problem number 2. Question, yes. Yes. Mm-hmm. So I'm just going to pause you for 1 second. I want to highlight something excellent that Nethman just said. She said there were 3 childs and not 3 children, because in computer programming, we need to, like, children is a totally separate thing than child. Children is an English concept of how you pluralize things. And when you're talking about code, you never want to use like English pluralizations of things, just add an S to things. There are 3 childs right here, because this child is not like the English semantic concept of a child. This child is just an arbitrary string, and we pluralize arbitrary strings by adding an S to them. So the right way to pronounce this is that there are 3 childs right here and not 3 children right here. Sorry, keep going. Yeah, so this foo right here, following the arrow, is pointing to this instance right here. And so this right here, this instance is this foo. Then this foo.child right here, follow the foo to this instance, get the child attribute, follow that to this instance right here. So this instance is foo.child. And then when we do foo.child.child, foo to the first child, starting at foo, this is what foo references, and then child, this is what foo.child references. Foo.child.child is this, which references this object right here. So this thing right here is what foo.child.child is. Foo.child.child.child is then this following that to here. So with it's easy looking at this Python tutor output to get the object itself confused with the attribute of the object. But like when we're talking about foo is referring to this foo.child. This is the literal variable foo.child, but that's referring to this instance over here. Did that answer your question? Good question. Number 2. Okay, so now we have 2 classes, and again, the foo class we call a subclass, and the foo class we call a superclass, and the bar class we call a subclass. The superclass is the thing that is more general, and the subclass is the thing that is more specific. Here, every bar is a foo, so it is more specific, but not every foo is a bar. Not every foo is a bar, so it is more general. And again, the way we know that there's this subclass relationship going on is with this parenthesis happening after the class name over here. This thing over here inside the parentheses is the superclass, and this thing over here is the subclass. Press next. Create both of these 2 objects up here. And inside Python tutor, we can see that the bar class over here extends foo. So this extends verb is another synonym for superclass and subclass, that we say that bar extends foo, or foo is extended by bar. Down here on 11, we're creating a foo instance on this line. So press next. This is a foo instance right here. We're inside the constructor for the foo class right here. And we're just setting the self.message equals to whatever the message was passed in. We have a default value up here that we could use, but in this case, one was provided for us, so we'll be using this value right here. And we're setting the instance value of message, the instance attribute of message, the value of the instance attribute to be equal to hello world right here. So I'll press next to run that line, and you can see the foo instance over here has the value for the message attribute of hello world. Press next, and that's everything that this constructor right here does. On 12, B right here, we're creating a B variable up here. And it is an instance of bar. So we're inside the constructor now for the bar class right here. Python tutor doesn't tell us that we're in the bar constructor right here. We just have to know that this init corresponds to this one right here, because the bar class was used down here as a function. Inside of that constructor, we're doing this super.init. So super always is going to refer to whatever the class is up here that you're extending. And then this .init is this init function up here. We're passing in the message. Press next, come up here. And now our message, hola mundo. Press next right here. When we do self.message, we're inside of the foo class right now, but this self still refers to this bar instance down here because this self comes from this self right here, which comes from this right here, which is what B is going to be equal to. And so when I press next right here, we created this message attribute in this bar instance of hola mundo. And that's the entirety of the setup of the problem. No message attributes up here, two different message attributes in the instances. Down here, when I do the a.bar function right here, press next, press next. The A is an instance, A right here is an instance of foo and is not an instance of bar. So when we look at the foo instance right here, we see there is no bar attribute here. That's okay. We don't immediately throw the attribute error. Instead, we go to the foo class up here, the foo class up here, and try to find a bar attribute. There is no bar attribute right here, and the foo class does not extend anything, so we are done. There's nothing that we can do, so we get this attribute error, and coming into the try except block, printing out the attribute error. The important thing here is because bar is the subclass of foo, foo does not have access to anything inside of bar. So foo, the A variable right here is a foo. It does not have access to anything inside of bar, like this bar attribute method right here. The bar class, the B variable right here, would have access to everything inside of foo. And so if I did b.foo, that would be totally okay. But a.bar, not okay. Any questions about this problem? Yeah. Question is, what would b.foo give us? And it would give us the exact same thing as b.bar because foo and bar are equivalent functions, just giving out self.message. And so it's printing out hola mundo right here because in the B variable, the message attribute is hola mundo. And the foo function right here is doing self.message. So even though this function is inside of the foo class, we do not look at foo instances in order to figure out what the message is. This self right here is referring to this B variable, which has type bar, but that's totally okay because bar, this B has a message inside of it. And so even though we're inside of the foo class, the message that we try to access will be part of this bar instance down here and be the hola mundo. So this is not the answer for the quiz problem. This is the answer if I had said b.foo instead of a.bar. A.bar gave us the attribute there. Good question. Any other questions? Okay, number 3. So now we have our foo and bar, call this a class hierarchy because foo is above bar, foo is extended by bar, now the difference about our class hierarchy is that now we have these static methods inside of both of these classes here. And so A equals foo of hello world. This is going to be exactly the same as what we were just talking about. We have this constructor right here. And now I guess the constructor is a little bit different. It has this if statement inside of it, if message. We've seen this before that our message here is not an empty string, so it is truthy in Python. So we go inside the if statement right here. And now when we do foo.message equals message, this is not self.message, this is foo.message. So it's changing the message attribute of the foo class. The foo class up here already has a message attribute of salve mundi because inside of the foo class definition right here, I just directly wrote message equals salve mundi. And so this is an attribute of the class up here and not an attribute of any particular instance. Here, foo.message, this is going to be referring to this message right here. So we will be overwriting Salve Mundi with our new message value, which is hello world. Press next. You can see over here, this changed from Salve Mundi to hello world. That's the end of our constructor. So come down here, and now we're on to b equals bar. Press next, we're going into this constructor right here. And now we are going into the superclasses constructor. So coming back up here to this init method up here, press next. And our message in this init constructor right here is none, because our default value in this message was none, and we did not pass anything in here for bar. And so now when we have this if message, none is falsy, we're not going into that message, and that is the entirety of our problem setup. Neither of these instances have message attributes, and the bar class does not have a message attribute, but the foo class does have a message attribute. But because the foo class has a message attribute, and all of these three things down here, all three of these objects will look for a message attribute in the foo class. If they don't have it, then we can access this message from the bar class or the A foo instance or the B foo instance, and that'll be totally okay. On line 18 here, we're doing b.bar. So b.bar is going to take us into this bar function right here. This is a static method right here, static method. So that means there is no self variable being passed in right here. And it's totally okay to do an instance dot static method, but it's also okay to do a class dot static method. b.bar is the exact same thing as bar.bar. So if I press next right here, we'll go inside of this. Whoops, I have breakpoints here. I'll go inside. So here's where we were before at this static method, and we're going inside of the static method, and what we're returning here is bar.message. Because we're inside of this static method, there is no self variable right here. We're calling this from an instance object, but we do not have access to that instance object inside of this variable, inside of this function, inside of this method. We only have access to the class object itself. And so here in the return, it has to be bar.message. It cannot be self.message because there is no self variable right here. So we have bar.message that we are returning. Bar.message, there is no message attribute for the bar class, but again, it extends foo. So we look at the foo class. Here is the message attribute, and it says hello world. We'll press next, and then that will be our final output up here, printing hello world. Any questions about problem number 3? Yes. Question is, what about a.bar? The answer is that if we change this to a.bar right here, then A is an instance. So I'm going to put a breakpoint right here. That means the code will run all the way up to that, but not including that. And actually, I want to put the breakpoint right here. So we create the constructor. And if we have a.bar instead of b.bar, this bar function, when we do a.bar, it'll look in the foo instance for a bar attribute or a bar method. It does not find the bar attribute inside of the foo instance. So it'll go up to this foo class, try to find the bar attribute. It does not exist inside of this foo class. And again, because foo is the superclass, bar is the subclass, we never go from a superclass to a subclass, only from the subclass to a superclass. We only go from the class that is doing the extending to the class that was extended. And so this bar attribute is not going to be found, and we'll get that attribute error. So if we had changed it so that it was a.bar instead of b.bar, then we would get the attribute error. But the original problem had b.bar, so the original problem gave us hello world instead of attribute error. Because the bar attribute or bar method does not exist inside foo. Yep. Great questions. Any other questions? Yes. Exactly. This is just a one-way communication channel that the bar class has access to foo because bar extends foo, but foo does not have access to bar because foo does not extend bar. Foo is extended by bar. Yes. Could you have, so the question is, are there like more complicated class relationships that you can have here about like circular extending where things extend each other simultaneously? Or the answer is that there are much, much more complicated sort of class hierarchies. In Python, it is not possible with default syntax to have a circular extension of things. But if you dig under the hood, it is possible to like create those situations. It is possible to have a class that extends multiple classes. It's possible to have a class be extended by multiple classes. These class hierarchies can get very, very complicated. These complicated class hierarchies basically have no like practical applications though, so we won't be talking about those more complicated class hierarchies. The most complicated class hierarchy that we'll have is from the binary tree containers homework, where the binary tree is going to be extended by, and it'll end up being by 4 different other subclasses, and but it'll be a much more straightforward relationship. But yes, good question. These things do get more complicated. Some data structures classes cover the more complicated relations. We're not doing it though, because nobody ever does that in practice. Last problem, number 4 here. Here is something that people do in practice quite a lot, and that is extending base classes, or extending more generally classes that you did not write, extending classes that somebody else wrote. And so here we have a class foo, and this is extending the list class inside of Python. I use the term base class over here instead of superclass. That's also a synonym. A base class, though, is specifically a superclass that has no further superclasses. So it is a class that does not extend anything else. Here, we're creating our foo instance right here. And now that we have this foo instance, this X, well, let's see. Before I get that, let's just run through this constructor here. You can see there's crazy arrows going all over the place up here. The key hard thing about this problem is that there is this XS variable up here. This XS variable corresponds to this in the Python tutor visualization. And again, this variable has a default value. This object over here is not recreated every time we call this constructor function. Instead, the object is created only once, and every time we modify this object, it modifies it for all future calls of the constructor. So this is tying into our memory management concepts as well here. Press next. Here we'll run the superclass of the constructor of the superclass, so the constructor of the list right here. And the list constructor just puts all the values inside of the list. It doesn't get displayed over here because there's no like corresponding variable that this corresponds to. It's just inside of the instance. It just exists. The number 4 right here, line 4, xs.append here. Now we're adding the length of our xs variable onto the xs list. Here, this xs list in both cases. So this xs corresponds to this one right here. This xs inside the function corresponds to this xs right here. This xs up here corresponds to this one up here. But they're both pointing to the same object down here. They're both pointing to the same object. So when I modify this list right here, doing xs.append, modifying this object right here, it's going to modify the object that this variable up here is also pointing to. I'm appending the length of xs. The length of this empty list is currently an empty list, so it's 0. I'll press next. And now you can see that this list over here that XS is referring to is just 0. Press next, and you can see up here that this list right here is has the 0 object, or the list that contains only the 0 inside of it, and so it has been modified. Now we're going to modify this XS right here, which is a totally different XS. It's inside the global frame. You can see that this one right here, this XS, is referring to a different foo instance, this one down here, and it is currently empty. When I did this append right here, this did not modify this XS right here. It only modified the one up here. This append, however, this append will modify this instance right here. In order to figure out what we're going to add to this instance right here, we are going to have to call the constructor again, and whatever the constructor creates is what we'll be adding. So let's press next, back into the constructor, back crazy arrows going all over the place. And now our XS inside of the constructor, the local variable XS, contains something inside of it, has a 0 inside of it right here. And so when I do this dot append right here, when I do the append, it's going to add something to this list. And now the length of this list over here is equal to 1. And so that's what it's going to add to this list over here. You can also see that when we called, I'll press back for a second here. When I call this superclass constructor right here, down here on the foo instance, it starts off as an empty list because we haven't called the constructor yet. When I call the superclass constructor, it adds this 0 into the list right here because currently this XS variable refers to the 0 list right here, the list containing just the 0 inside of it. Press next one more time, get us out of the constructor over here. And the summary takeaway of these first 2 lines is that our list up here, our default value has 0 and 1 inside of it now, but our foo instance that corresponds to the XS variable right here has a list of the 0. This thing inside of it right here that I'm highlighting, it may be hard to see, but I'm highlighting only the inner square brackets and not the outer square brackets. That is the contents, what was returned by this foo constructor right here. Now when we come up to line 7 right here, ys equals foo, this is going to again go inside of the constructor, and now the XS list over here, 0 and 1 inside of it. So that's what's going to be inside of our foo instance when we call this line right here. It'll have a two XS dot appends. I have a typo. This is what yours looks like. Thank you. Let's put a breakpoint there. So then everything's the same up until line 7 right here. Going through, we'll jump through line 7 real quick, see what it does. Everything that we've seen before, the pattern is that this XS up here is going to get extended by 1. So it'll go 0, 1, and then it'll have a 2 after it. And then the foo instance down here, yeah, maybe we'll just step through it. So here, this is creating the constructor right here is gonna, this foo instance, our new foo instance is gonna have 0, 1 inside of it, 0, 1 inside of it right there, 0, 1 inside of it. And then we'll modify this one over here to be 0, 1, 2. The 2 coming from the length of XS. And so this is what the XS foo instance looks like. It's very important, this other line right here, calling this other constructor right here, because calling this constructor is going to, has modified this default value up here. So the future things down here will be affected by that. Coming on to line 8 now, here, ys, we have our foo instance is 0, 1, 2 at this point. So that's what we are adding into our foo list, our XS self right here, 0, 1, 2. And then we'll add on to the XS up here, making it 0, 1, 2, 3. And come back down here. This is what my ys variable looks like right now, 0, 1, 2. And I'm going to jump over both of these two lines because they do all the same things that we've seen before, but they also don't have any effect on the output. The output down here, when we see ys square bracket 2, is going to tell us what is at, or it's going to ask for us what's at position 2, and we already know what's going to be at position 2. None of the code that we've seen before modifies any of the positions that are already existing. It only adds new things in here. So if I'll make us we'll jump over both of them at once. Pause that there. The things that got added to our foo instance over here are more lists right here, but this is still the position 2, hasn't been modified at all. And so our final output, scrolling up to the it doesn't have a print box up here, does it? Why doesn't it have a print box? Let's edit this code, visualize execution, go to last. I added the length in there. I apologize for that. This is what I had intended, which would have printed 2. But because I had this mistake of, I guess I got confused about whether I added this or not added this, then it was giving the type error. So everybody gets full credit on this problem. So the hardest problem, everybody got full credit on because I made a mistake. So I apologize for that, but maybe also you're welcome since you get 2 points. Any questions on this 4th problem? Or about anything related to the quiz material, classes, superclasses, static methods? Again, yes. So here, the question is, what exactly would the answer have been? The answer is that based on the problem statement, there is no it doesn't print anything, so leaving it blank would be the most correct thing. You're getting a type error right here when you take the length. This is an integer. The length of an integer is a type error. Each problem 2 points, so overall 8 points. Oh, the Monday recording. It's not any other quizzes? Put it up here. Okay. So quick reminder from Monday that the homework that is about binary trees, I delayed until Thursday instead of Tuesday this week. So you have another 30-ish hours to work on it without a late penalty. And the homework for next week is due Tuesday. Rather than talking about it in class, though, I've posted these 2 videos right here for you all to refer to. This is so that we have time to finish all the material that we need to before I'll be going on the paternity leave later in the semester. Both of these videos are from previous versions of this class. And I thought about re-recording things just for this class, but there are really good questions in these videos that students asked. So I thought you all might appreciate hearing those questions and getting those answers. So these are the videos that you'll need for the AVL tree assignment, which is the assignment due next week. In class this week, we're focusing on quiz material. Last class period, we did this POSIX I shell quiz. This class period, we will be doing this POSIX shell 2 practice problems, reviewing all the material here. As a reminder, POSIX is this portable operating system interface. It's a really old thing from the 1970s, so it's 50 years old at this point. And but there's no signs of it going away. It's only becoming more and more used around the world in different locations. And as an example of that, it now works on all computers that people commonly use. So Windows recently added support in 2016. Any of your, like if you have like Macs or Linux machines, they work on it. All of your cell phones have this POSIX things installed inside of it. If you have smartwatches, those have POSIX installed inside of it. And even today, there are a lot of actual toasters that you can connect to and use all of these POSIX commands on them. So very, very widely used all over the place, common interface for working in different computing environments. We talked high level about lots of advantages of these POSIX operating system interface using this shell terminal. The main thing that's going to be important for us is one of your last assignments in this class is working on Twitter data. You'll be processing 3 terabytes of tweets. And in order to do that efficiently, you'll need to be able to use these shell commands in order to do it. The very strong disadvantage, though, of this POSIX shell is it's extremely weird and awkward to use. And so it takes a lot of getting used to in order to be able to use it efficiently. Before starting the new POSIX II material, I'll do a quick review of the highlights of the POSIX I things. Yes, question? Good questions. The question is about the upcoming homework assignments. So the BST right here is due this week, AVL tree due next week. Full collaboration allowed on this one. It's this assignment right here, this heap assignment, that you won't have collaboration available. And but we will go through this assignment here in class next week. Yeah. The question is, what exactly does the no collaboration entail? You won't be allowed to ask anything related to this topic at the QCL or talk with your friends about it. You would be allowed to come to office hours, but it's the intent is that like you are given you're going to a company doing an interview and they are wanting you to implement something in the interview situation and to reproduce that environment as much as possible. So the internet resources would be totally okay. Asking clarifying questions, totally okay. But outside help, not okay. So again, on these next 2 assignments, don't make extra efforts to make sure that you're understanding the principles of how to complete the assignments so that when you get to this one, you'll be able to just focus on the actual implementation and not worry about other outside things. Good questions. Any questions about anything else administrative? Yes. The BST is not posted on Sakai. Is that binary tree? Then I will make that visible for you all after class. Apologize about that. Any other administrative things? Yeah. The pictures. Yeah, there you'll have to add those yourself into the README. I believe the instructions down here mention doing that somehow. But there's, yeah, pay particular attention to the instructions down here. There's a lot of small weird things. Um, but yes, good question. Okay, so quick review of the highlights from last time. That well, first of all, I'm on the Lambda server right now, and I just ran our like quiz initialization problem, just so that we're in a quiz folder that's totally empty. Last time, what we talked about was working with variables inside of the shell. If we have something like var equals, the important thing with variables is that you never have spaces after or before the equal sign. Whatever you're assigning this variable to there must not be any spaces. And then inside of quotation marks, something like hello world like this. And then when you want to reference the variable, it's a $sign var, and that references the variable. So creating the variable, no $sign, accessing the variable, need a $sign. If you forget the $sign, it'll just literally output the word var. Inside of quotation marks, so single quotation marks, the $sign never gets expanded inside of single quotation marks. Inside of double quotation marks, the $sign does get expanded into the variable. For the echo command, there's no difference between quotation marks and no quotation marks. But for in general, there is differences between quotation marks and no quotation marks. And the touch command is how this will appear on your quiz to make sure you understand the difference here. If let's first just verify again, there's no files inside of my current directory. If I say touch $sign var like this without quotation marks, this literally gets expanded. The shell copies and pastes the value of the variable right here. And so it gets expanded into being touch hello and world like this. And these are interpreted as two separate arguments to this touch command. In this case, two separate files to the touch command that it's going to create. And so if I type ls right here, or ls pipe cat to make it a little bit more obvious that these are two separate files right here. Again, the pipe command takes the output of the leftmost command and passes it as the input to the rightmost command. And a lot of the quiz problems use pipe and then the wc-l to count the number of lines in the previous command, or in the particular case of ls, to count the number of files in the folder. If so this is what happens without the $sign right here. Because there's a space in the variable right here, because there's a space right here, both of these two things get treated as separate arguments to this touch command. Let's go ahead and do rm hello, rm world, ls. There's nothing in the folder anymore. If I redo my touch command saying touch $sign var like this inside of quotation marks. Now when this command again is equivalent to copying and pasting this var right here into hello space world like this, these two commands, these two lines right here, 100% equivalent to each other. And so this is inside of quotation marks. The shell will pass this as a single thing to the touch program. Touch will interpret this as just one file to create. And so if I type ls, we see that there's only a single file right here, puts it inside quotation marks. So I know that this space is not separating out two separate file names. Or if I did ls pipe wc-l, we get only one file as the result. This is all review from the first POSIX quiz. The second POSIX quiz starts off with a variation of this using the question. Yes. Question is, if the output final results of the quiz, the command that I'm asking you to write the output for was just ls by itself, would you, should you put quotation marks around like this? The answer is that you should somehow indicate that, yes, this is just a single file and not two separate files. For the purposes of this quiz, though, it will always be like ls pipe wc-l. So you're going to be just like writing out a number down here about how many things there are. If I did, so maybe another variation here, ls-a pipe wc-l. Again, the -a is standing for all, so it gets the hidden files as well. So it gets this dot in this dot thing as well down here. The new quiz, quiz number 2. It starts off with a new variation of these quotation marks using something called here documents, which we have seen a little bit before. So I'm going to illustrate the concept, and then we'll go over to the quiz and see how that applies to the quiz. I'll start by resetting my terminal, clearing the screen, Control R, get that CD command out here to reset everything. And now let's just verify that the VAR variable still exists. And we'll see our new concept. So the cat program, again, you can make the output go to an individual file, go to a file with the greater than sign. If I did something like cat foo, then cat, again, will take the input from whatever I'm typing in right here. Hello world, salve mundi, hola mundo, like this. I press Control D to end that. Type ls right here. Here's the foo file created by this output redirection right here. The greater than sign says, the way to think about it is this is like an arrow saying whatever the output from cat is, send it over to this foo file right here. It's put in this foo file right here. And now I can output the foo file like this. Cat here was not, or takes its input from standard in, from typing things in on the keyboard. And so all of this was the input to cat. Cat just outputs whatever it gets as input. And so the output here going into the foo file like that. Another way to use the cat command, a little bit more streamlined in this case, is with this here document syntax like this. Here I have 2 less than signs and then this EOF standing for end of file. And so we've seen this before on your Python quizzes. I've been using this syntax to put things into files, Python files, so that we can run them. And so let's do something like hello world right here and then EOF right here. And this will output into the bar file this contents of hello world. This is all, again, review from things that we've seen before. But now we're going to combine this here document syntax with these variables and quotation marks that we were talking about on Monday and see how weird things can get. So again, we have this VAR variable. What will happen if we include the VAR variable inside of the here document? I'm going to press the up arrow, up arrow, up arrow to get back to this here document. You can see that it's taking up multiple lines down here on the bash shell. I can use my left and right arrow to go back to the previous lines, but I cannot use the up and down arrow because the up and down arrow takes me to previous commands. So only the left and the right arrow. And what I'm going to do is I will just replace this hello world with $VAR like this. $VAR like this. And we're going to see what is the contents of this bar file. What did cat put in the bar file? Whatever cat put in the bar file is going to be what the contents of this VAR or what the contents of this here document is. If I do cat bar like this, we can see that it contains hello world inside of it. If I do rm bar, so that the bar file doesn't exist, up arrow, up arrow, up arrow, up arrow, rerun this command right here with the $VAR. Inside of these here documents, inside of the here documents, the dollar signs do get expanded. And so instead of $var inside this file, we get hello world. So the here document, the EOF, behaves like the double quotation marks. The exception to that is if I put single quotation marks around the EOF. So I put single quotation marks around EOF like this, and now this here document will behave like the single quotation marks instead of the double quotation marks. I hit enter like that, and now I type cat var like that, and I get $var down here instead of the hello world. So with single quotation marks around the EOF, the variable $ expansion does not happen. But with no quotation marks around the EOF, the variable expansion will happen. All of the quiz problems in quiz 2 have these here documents with this the EOF, and some of them have the single quotation marks and some of them have no single quotation marks. So you'll really have to understand this point in order to get these quiz problems correct. Question? So the question is, how is this going to affect the actual code inside of the file that we'll be writing? And that's what we're going to come to in these first problems. The first thing to note is that, so here all of my examples are with files named bar and foo. Let's reset my problem. I'll rerun this initialization thing. Let's reset the screen and type ls. There's no files right here. And you'll see here in this, where'd it go? I'm gonna just enter this first quiz problem into the terminal. We'll talk about all the details of what's going on here. The first thing here, when I do the cat greater than quiz.sh, cat greater than quiz.sh, and then here document EOF like that. This file quiz.sh ends in this sh extension. And again, this is just a string. So from the computer's perspective, it has no semantic meaning. But to a human, if you see things that end in sh, this should tell you that this is going to be a shell script file and not a Python file. And so down here we have foo equals hello world, foo equals hello world, and or just hello. That's okay. If $foo equals, I'll make them both hello world, then touch if, and fee. The beginning of if statements inside of the shell script looks sort of like Python. It has this if statement right here, and then we use square brackets to contain the actual condition of the if statement. Inside of the terminal, when we're using an equals, it must be a single equal sign and not a double equal sign. A single equal sign is for an equality check in the terminal. Python single equals is only for assignment, but in the shell script in POSIX, the single equal sign is for the equality check. And the square brackets contain our actual condition. Then semicolon, then whatever is between the if and the fee statement down here is what's going to get executed in our shell script. Then down here, I'll type EOF to end that. So this is not executing any of this code right here. Instead, it's just creating this file quiz.sh that contains this code right here. If I do cat quiz.sh, I can see that here is all of the contents of this code right here. In order to actually execute a shell script, the command is sh, and then quiz, then the name of the file that you want to execute, like that, and it will run through whatever the code is. Looks like I have I'm going to edit this. I got ahead of myself adding the space right here on accident. So foo equals hello, $foo equals hello world, cat quiz.sh. I believe this is the actual contents of what I put on the first problem with the quiz, and sh quiz.sh. It runs it, just goes through line by line as if you were typing it into the terminal. It's like copying it and pasting it into these terminal sessions right here. And so if I type ls now, I have the quiz.sh file created during this session right here. This command right here creates the quiz.sh file. And then this command right here, touch if creates this if file right here. Touch if creates this if file. Here in this case, the foo hello right here, hello gets substituted right here for this variable. And so it says hello equals hello. Those two things are equal. And so it does go inside of this if statement. And then touch if creates the if file right here. I'm going to do a couple of variations on this, and then I'll stop for questions. I'm going to open this up inside of Vim. And I want to highlight what's going on with this touch if. So the first thing that I'm going to do is I'm going to change this condition here on the right-hand side. So now this thing on the left is hello. This thing on the right is just he. So this is going to evaluate to false, and we will not execute the thing that's contained in the if statement right here. So we'll save that. Cat quiz.sh. Here is the new contents of my program. It contains he right here instead of hello. And so we're not going to run this piece of code. In order to verify that, I'm going to delete the if statement, the if file right here. But I don't want to delete the quiz file because the quiz file is the thing that I'm about to run. When I do sh quiz.sh like this, then again, this program right here does no output. But if I type ls, you can see there is no if file that's been created because this statement right here never got ran. This evaluates to false, so this doesn't get run. Python is what we call white space sensitive. Python is white space sensitive. And so the way Python knows what's inside an if statement is through indentation. Whether you indent this line is what determines whether this is inside the if statement or not in Python. But the shell is not white space. The shell is not white space sensitive. Shell is not white space sensitive. And so you do not need to indent things. Having this touch if not indented is totally okay. And the way the shell knows that this is inside the if statement is because it starts with the if and ends with the fee. Everything between then and fee will be inside of this if statement right here. If I save and run that, rerun this file, we'll see that this touch if command right here still not getting run because this is evaluating to false. And this is inside of the if statement, even though it's not indented. We know it's inside of the if statement because everything that comes between the then and the fee will get executed inside the if statement when this is true up here. One last variation here. Up here, the very first thing that I did was I did hello world up here and hello world down here. And what's happening when I do this is that, again, anytime you have the $sign, it's going to get substituted exactly how it is. And so I'll press YYP to yank and paste that, up arrow, insert, comment that out. This line below is 100% equivalent to this line. So this line right here is 100% equivalent to this line right here. That when this $sign is encountered, then when this $sign is encountered, it just copies and pastes the value of the variable right here. And that's the end of the story. When we do this though, the shell sees the word hello and it's expecting an operator after the word hello because there's a space right here. We have hello space world. It's expecting there to be an operator after hello, like an equal sign after hello, but there's not. And so we're getting a problem. We get that error message. Control WQ, cat quiz.sh. Here's the contents of the quiz file right now. And again, the important thing is this if statement right here. If I do sh quiz.sh, this is the first error message that I was getting with the square bracket right here saying hello, unexpected operator. The hello corresponds to the first variable right here that got substituted, and then it's expecting something like an equal sign or a greater than sign after the hello. Vast majority of times when you're using variables inside of bash, you want to put quotation marks around them like that, so that when it gets expanded, it'll have quotation marks around the expansion. And now the shell will know that this whole thing right here is lumped together. It's a single thing to the left of the equal sign. And so we'll compare this to this over here. This is now a valid thing to do. And no more error message. So it's in particular because I put the quotation marks, the double quotation marks around $foo right here. This $foo is getting expanded to that, and so we're good. Those two things are equal to each other. If I type ls, then we get the output down here. I guess one last variation. If instead of the double quotation marks, I put the single quotation marks like this, then again, variable expansion does not happen inside of single quotation marks. And so this is literally just $foo. The $foo is not equal to hello world. And so this will not generate a file for me. rmif lsquiz.sh does not generate a file for me because $foo as the little string is not equal to hello world. Only $foo with the variable substitution is equal to hello world. Okay, now we'll pause, come up for breath. We're basically at the end of our time though. So I realize a lot of you had questions. If you still have questions, happy to take them after class. Otherwise, we'll review this and pick it up on next week.